The purpose of this tutorial is to provide an example for how to illustrate attributes changes while your model is running. So first thing is to understand that any property of the system that is per item needs to be handled by attributes rather than separate blocks within the model. So in the zombies baseline model, that would be things like zombie speed, for example. So in this tutorial, we're going to show you how to adjust the zombie speed during the model. So if we want to change this model so that rather than when the zombie is shot, right now there's two possibilities, either you hit or you missed, in which case the zombie dies immediately. In the baseline model, the zombies do not have health points. Suppose we want to change this so that there's three possible outcomes: miss, kill, and wound. So right now we have miss and kill. If we want to add that wound outcome, then we're going to need to have some effect from the wound happening, and that's where the attributes come in. So in this model concept, if the zombie's wounded, what happens is they keep coming at you, but the amount of speed that they have changes based on a random variable to simulate where they've been hit. So in order to do that, the first thing we need to do is think about the attribute that's going to be changed, in this case, speed. That attribute has to be initialized in the model in the first place. In the zombies baseline model, that initialization happens in block 1. Now here the zombie speed is pushed in from the database, but that happens inside the set block. So whatever attribute you want to deal with needs to be set up inside the set block. If it's already in the set block, you'll see it there, and then you don't need to do anything else. If it's not inside the set block, you're going to have to add another row to the attributes table and then set up that attribute. Okay, so we already have speed set up, so we're going to use the speed here in order to decrement it if we get wounded. So the first step, we already ensured that the speed is set up inside block 1. We now want to change the random variable that we have to have 3 possible outcomes instead of 2. So changing it to 3 possible outcomes, we do that by using an empirical table. So that's empirical table is another distribution. And what that does is let us set each outcome according to a probability. There's several settings to this empirical table that I'm not going to go into, but for now we're just going to choose outcome 1, 2, or 3. So actually I'm going to choose 3 outcomes being 0, 1, and 2. And the reason for 0, 1, and 2 is because those possible outcomes will represent the 3 possibilities of the output connectors. So the reason for using 0, 1, and 2 is it fits a little more naturally with the way the select out block works. So we have outcome 0, and we want to have the outcome 0 is going to be the zombie lives, or I guess comes back, not really lives, but at any rate, we haven't done any damage to the zombie. So I'm going to just assign that 25% probability we just miss entirely. Outcome number 1 is going to be zombie shot. And that outcome, we're going to say, well, we have a 50% chance of shooting the zombie, which leaves me with outcome number 2, wounded. And we're going to have a 25% chance of having that. Now you'll notice that the red disappears, telling us that we have 100% of the outcomes covered. Okay, so this is going to generate choices 1 to 3. And then the third outcome, I have to add in. So what I'm going to do when I add in that third outcome, I'm going to use an equation block. There's only two ways to change attributes while you're running. One is to use a set block, similar to what's being done here. And if we have a fixed value that we want to push in to that attribute, that works. If we have an attribute that we want to change based on the present attribute value, in this case, the zombie already has a speed. If the zombie gets shot, we want the speed to decrease. So using a get and set pair is a little bit more awkward than just using an equation block. So we're going to go get an item equation block. And this allows us to modify that item as it passes through the equation block. Now, when we pass through the equation block, the zombie's been wounded, so it's going to go back to the same place it would if it hadn't been shot at all. So I'm going to duplicate that throw. And now we're going to go inside the equation block to actually put the code in. So inside this equation block, we're looking again to modify the speed. We already know that the speed needs to be modified because we have the three separate outcomes from the select out block. And we know we're on the outcome that we definitely had some level of wounding. So how do we decide how much wounding that we have each time? If we want to use that from a random variable, you can program in the random variables from within the equation block, or we can get those random values from an output connector and then use the random block. It's a little bit easier to use the random block just because then you can choose the distribution from a drop-down instead of having to look up how to use the distribution with modal. So in order to leverage the random block, our first connector, so connector 0, we don't want to label this incon 0. That's just bad programming practice. We want a meaningful variable name. So I'm going to label that damage amount. Again, no spaces because this is the name of a variable inside a program. So we have the same variable naming rules as we would for any other kind of programming language. You can't start with a number, and you can't have special characters except underscore in your variable names. So we get that the amount of damage amount is now an incoming variable. And we also need, if we're going to modify the speed, that speed has to be an incoming variable. So we're going to add a new row. And we'll resize to the total number of rows, which is 2. Now for the second row, we want that to be an attribute. Once we tell it we want an attribute, notice that we have a choice of inserting a new attribute at this point, which we're not going to do because we already have the attribute speed set up inside this model. So we simply choose the attribute speed. Now, before we get started on the programming, we want to think about what the output from this equation is going to be. Well, we don't need any output as far as telling other parts of the model what's going on. So we don't need a connector output, but we do need the attribute speed, the changes to actually stick. So to get those to stick, we have to go on the output variable side and choose an attribute and then choose speed. And that way we have speed as an incoming variable inside the block. We make the changes via this equation text, and then the output variable pushes the speed out and makes it stick in the attribute. So we need both parts, the input and the output, for this to work. So what we're going to do is we're going to decrement the speed by the percentage, whatever damage amount is being passed in here. So we're going to say that speed, so the incoming speed or the outgoing speed is going to be the same speed that we had before times whatever this damage amount is. So we're going to set up the damage amount as being some percentage. So each time we get wounded, we just degrade the amount of speed that the zombie has. Now, if we get wounded repeatedly, it's likely that we may have some type of a problem with the zombies no longer being able to move and just sitting there. And so that we could decide, well, this is a problem and we want to declare this zombie dead and removed from the model, because is the good guy really going to waste their time aiming at a zombie who's, you know, on the ground and not moving at all? That would be something to address later in the modeling. For now, we're just going to leave the speed decrementing, even if it decrements all the way down to 0. But in the long run, that may be a problem for the model, and we may have to do something to signal the rest of the model that this zombie needs to actually exit from that point. But we're not looking at that just quite yet. So now we want to push the test equation button. If you just see it blink momentarily and I don't see an error message, then we've done everything that we need to do correctly. It can be helpful when you do equations to show the input and output connector labels. That way we can be sure when if we're hooking up multiple things to those labels that we're getting the correct ones. So now we notice that we have a damage amount here. That damage amount needs to be specified by a random variable. So we go to our value library and we choose a random variable. And in this case, I'm just going to say it's a uniform real. So the percentage damage I can have is, I want to retain anywhere from 50 to 75%. Let's say 90%. So again, each time you hit the zombie, this is going to accumulate. The amount of damage will accumulate. So you don't want to set it too low. Otherwise, the zombie will, you know, just go to a crawl very rapidly. Okay, now we hook up the random variable. And let's go ahead and test our model. So to test our model, anytime you're making a test to an attribute, you want to test with one zombie only. So we're going to test with one zombie only. If you test with more than one zombie when you do attributes, when you do any plotting, you're going to see mixtures from more than one individual, and it's very hard to tell whether or not you're getting the intended behavior. Okay, so to help us understand whether or not we're getting this decrement over time, what we're going to do is have an output going over to the plotter to show us the amount of speed. And so to do that, we're going to put in, we could either output the speed into a connector, or we can use a get block. I'm just going to go ahead and use a get block for illustrative purposes. So a get block allows you to look at an attribute of a passing item. So now we need to set up which attribute we're looking at. And in this case, we're looking at speed. And then click the OK button. And now notice we have a connector here that's going to tell us that speed. Now we can put the speed into the plotter, and we should be able to see the plotter on the plotter that this speed is decreasing over time. Okay, so we're going to run it with the animation off so it goes quickly. Now this is a different discrete event plotter that's popping up, which is Blue Health. Now notice here that the speed decreased. So if we want to make sure that this is really happening multiple times, we'll just make it show this plot automatically at the end of the simulation. And then we can make the other plot not pop up. It just makes the testing a little bit less annoying. Okay, so we're going to run this simulation repeatedly, and then we should be able to see the decrement several times. Okay, so now this time we didn't go through ever, so the zombie got shot right away, and that's going to happen a certain number of times. What we can do to try to make our testing a little bit easier to do here is I'm just going to always pass it through the wounded. So I'm going to change my multinomial here. I'm going to change it temporarily to be a constant. And I'm going to change that constant to be 3. So I'm going to, or I'm sorry, 2. So I'm picking pathway number 2. So now I can see that this zombie speed is consistently degrading over time like I would expect it. So notice we start the attribute, and this attribute is indeed decreasing over time each time I get hit, just like I would expect. And this is the end of the tutorial, since it appears that we've successfully implemented this feature.